MCP communication flow, step-by-step flow walkthrough. Let's dive deep into how the Model Context Protocol actually works under the hood. MCP is the communication standard that enables AI agents like Claude to interact with external tools and resources in a structured, reliable way. What you're seeing here is the complete communication dance between three key players: the MCP client, which could be an IDE, an AI agent, or any user interface; the MCP host, which acts as a broker and coordinator; and the MCP server, which provides the actual tools and resources. This isn't just theoretical. This is exactly how Claude Code accesses documentation, how it retrieves specific information, and how it executes tools to help you build better code. Let's walk through each step of this sophisticated protocol. Step 1. Start and connect. Everything begins with step 1, start and connect. The MCP client, let's say it's your IDE or the Claude interface, initiates a connection to the MCP host. This connection can happen through multiple channels. It might be a standard WebSocket for web-based applications, local IPC, inter-process communication for desktop applications, or even standard I/O for command line tools. The beauty of MCP is that it's transport agnostic, meaning it can work over any reliable communication channel. Think of this as the initial handshake where the client says, "Hey, I'm here and I need access to some tools and resources." Step 2. Host loads server adapters. Once the client connects, the host springs into action with step 2, loading the server adapters. This is where the magic of MCP's architecture really shines. The MCP host doesn't just connect to one server, it can manage multiple MCP servers simultaneously. In our Claude Code example, this might mean connecting to a documentation server, a code execution server, and maybe even a web search server all at the same time. The host locates these servers, spawns the necessary processes, and establishes connections with each one. It's essentially becoming the central nervous system that will coordinate all communication between your client and these various specialized servers. This step is crucial because it sets up the entire ecosystem of tools and resources that will be available to your AI agent. Step 3. Initialize. Client to host to server. Step 3 kicks off the initialization sequence, and notice how this flows through all three components: client to host to server. The client sends an initialization request to the host, essentially saying, "I'm ready to start working, please set everything up." The host then forwards this initialization request to each connected server. This is where each server gets the chance to prepare itself, load any necessary resources, and get ready to handle requests. For a documentation server, this might mean indexing available documents. For a code execution server, this might mean setting up a secure sandbox environment. It's like the moment before a symphony begins. Everyone is tuning their instruments and getting ready to play their part. Step 4. Capabilities handshake. Now comes one of the most important steps, the capabilities handshake in step 4. This flows in reverse, from server to host to client. Each MCP server advertises what it can do, what tools it provides, what resources it has access to, what file formats it supports, and any special features it offers. The documentation server might advertise tools like search docs and Git content, while a web search server might offer web search and summarize results. The host collects all these capabilities from every connected server and presents them as a unified catalog to the client. This is where the client discovers what's possible. It's like being handed the menu of every tool and resource available across the entire ecosystem. The client then records what's available, and this becomes the foundation for all future interactions. The AI agent now knows exactly what tools it can call and what each tool is capable of doing. Step 5. Discover resources and tools. Step 5 involves the discovery process where the client asks for detailed resource and tool lists, and the host relays this request to the appropriate servers. This goes beyond the initial capabilities handshake. Now the client is asking for specific catalogs. Show me all available documentation files, or list all the code analysis tools you have, or what web search capabilities are available. Each server responds with detailed schemas, usage examples, and parameter specifications. The host collects all these responses and sends back comprehensive catalogs to the client. This step is like opening the detailed manual for each tool. The client now knows not just what's available, but exactly how to use each tool, what parameters it expects, and what kind of results it will return. Step 6. Server returns resource catalogs. Step 6 is the response to the discovery request. The servers send back their detailed catalogs, complete schemas, available resources, usage limits, and any special requirements. For our Claude Code example, this might include a catalog of all LangChain documentation files, their organization structure, search capabilities, and access patterns. The client now has a complete roadmap of everything it can access and how to access it effectively. Step 7. Invoke tool, get resource. Here's where the real work happens. Step 7 is the invoke and execute phase. The client makes a specific request. I need to search the LangChain documentation for information about streaming, or execute this code snippet and return the results. The host receives this request and forwards it to the appropriate server. Notice how the host acts as an intelligent router. It knows which server can handle which type of request and ensures the message gets to the right destination. This is the step that happens most frequently during an AI coding session. Every time Claude needs to look up documentation, execute code, or access any external resource, this invoke and execute cycle is what makes it possible. The beauty is that the client doesn't need to know the details of how each server works. It just makes standardized requests through the MCP protocol. Step 8. Optional streaming. Step 8 introduces an optional but powerful feature, real-time streaming. For long-running operations, servers can stream progress updates, logs, or partial results back to the client. Imagine Claude is analyzing a large code base or processing extensive documentation. Instead of waiting for the entire operation to complete, the server can stream progress updates, process 25% of files, found 3 relevant documentation sections, currently analyzing function definitions. The host relays these streaming updates to the client in near real time, providing immediate feedback and allowing for a much more interactive and responsive experience. This is particularly valuable for operations that might take several seconds or minutes to complete. The user stays informed and engaged rather than wondering if anything is happening. Step 9. Result and data return. Step 9 delivers the final results. The server completes its operation and sends back the comprehensive response. This could be documentation content, analysis results, execution output, error messages, or any artifacts that were generated. The host receives these results and forwards them back to the client. The client now has everything it needs to continue with the task, whether that's displaying information to the user, using the results for further processing, or making additional tool calls based on what was discovered. Step 10. Client renders response. In Step 10, the client takes the received data and renders it appropriately for the end user or passes it to downstream agent logic. In Claude Code, this might mean displaying formatted documentation in the interface, showing code execution results, or using the retrieved information to generate better code suggestions. The client is responsible for making the server responses useful and accessible to the human user or the AI system. Step 11. Optional subscriptions and events. Step 11 introduces an advanced feature, subscriptions and event notifications. This allows the client to subscribe to ongoing events or resource changes. For example, Claude might subscribe to notifications about documentation updates, code repository changes, or system status alerts. When relevant events occur, the server can push notifications through the host to the client without waiting for a specific request. This creates a much more dynamic and responsive system. Instead of constantly polling for updates, the client can be proactively notified when something important changes in the resources it's monitoring. This is particularly valuable in development environments where code, documentation, or system status might change frequently. Step 12. Close and tear down. Finally, Step 12 handles the clean shutdown process. When the client is finished or needs to disconnect, it initiates the close sequence. The host receives the close request and properly detaches from all connected servers, ensuring that resources are freed up, temporary files are cleaned up, and all connections are gracefully terminated. This might seem like a minor detail, but proper cleanup is essential for system stability, especially in environments where MCP sessions are created and destroyed frequently throughout the development process. Key architectural insights. What makes this architecture so powerful is the clear separation of concerns and the broker pattern implemented by the MCP host. The client doesn't need to know the details of each server, it just makes standardized requests. The servers don't need to handle multiple client connections directly, they just focus on providing their specific capabilities. The host handles all the complexity of routing, connection management, and protocol coordination. This creates incredible flexibility. You can add new servers, upgrade existing ones, or even replace servers entirely without changing the client code.
The host can load balance requests, implement caching, or add security layers without affecting the other components. For Claude Code, this means it can seamlessly work with documentation servers, code execution environments, web search APIs, and any other MCP-compatible service through one unified interface.